All right, hey guys, here we're doing a question here. It says, which of the following integrals will you find the volume of the solid that is formed when this region is bounded by this function, okay, and this function here. And then they also give you x equals 1. So x equals 1 is here. Then this red function is this one right there. It's the e to the 2x. And then the y equals 1 is here, okay. So the y equals 1 I've made blue. And this one I've made red, all right? And here's my region right in there. And then not only that, you're going to revolve it around y equals -1, which is down here, okay? This was a multiple choice question, and they had a bunch of integrals as their answers. I'm just going to go ahead and actually solve the entire volume here, all right? So here, what I have is a generalized idea of how do you solve these questions when you have two functions and you have an axis that has been shifted away from the x-axis. So here it is. So what you do is you have a pi and a radius squared. This makes a large volume, okay? And you take away a smaller volume. So you kind of think about it like this. From this green line all the way up to the red function, this is going to create a area here that I'll then rotate around to create a volume. Then this one is going to be another area right here. This box is going to be this area. And I'm going to remove that from the larger red area. You can kind of imagine this is a big red area and then a blue area right in here. And basically what you have is the leftover is this white dashed area here. And this is sort of your general idea. So what did I write in here? In order to figure out this red volume, you basically have to find the radius, which is the distance from the axis of rotation to the red function, okay? And I always put the function that's furthest from the axis of rotation in this first one. And then over here to find the blue area, you take the difference between your axis of rotation and your other function, your blue function. In this case, this is the function closest to the axis of rotation. And what you're basically doing is creating a big volume, subtracting out a small volume, and you end up with this smaller area. And then you integrate it from A to B, which would be in this case from here to here, okay? And then because you're doing a pi r squared, what you're actually doing is you're doing a rotation there, all right? So this is sort of your general approach. And now this is a very easy thing. If you kind of remember this format, you just put your axis of rotation in right there. Look at that, -1. You put your function that's furthest here. You put your function that's closest here. So notice this is y equals 1. This is just this is a boring function, but it could be, a different function. It could be like x squared or something in here, all right? And then now you basically solve these two integrals, right? Now, because these integrals are the same, they both have a pi and they both have a 0 to 1 in them, you can recombine them or you can leave them separately, whatever you feel like doing. I started with them separated out, because it kind of gave us a good way of sort of thinking about these two separate volumes, okay? So now I just kind of did this exponential, -1 e blah, 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 did it to the square and wrote it here, okay? -1 to the -1 minus -1 squared is this, which is my -4, okay, which is here, all right? Then I just combined all this, and now I basically just have a simple little integral, right? And so I integrate this guy, and you can kind of follow this along. This doesn't need much explanation, is because this is a pretty basic integral. Same with this one, and same with this one. Then you evaluate it from 0 to 1. And so here is everything evaluated at 1, everything evaluated at 0, and then you kind of do all this. I did this in a hurry. Hopefully, I didn't make any mistakes in this area. But more or less, I think the part I wanted to focus on was this here, how to actually set these guys up, okay? And so it's axis of rotation minus the furthest function, and then over here is axis of rotation minus the closest function. And if you do it like this, you'll always end up getting a proper volume, even if your axis of rotation is shifted, right? And by the way, if your axis of rotation is the x-axis, you actually just write a 0 right here and here,